I spent past 12 years developing technologies for OEMs such as Rivian, Aston Martin, McLaren, and other car manufacturers. And after some time working for those companies, I realized there is a lot of potential for electric vehicles to have more efficient drivetrains. And then I set up the company called S-Drive, which it's now launched here at CES. And our first product is its in-wheel motor, which basically uses a hubless electric drivetrain, just integrated inside of the wheel. And this also includes the braking system and everything what electric car needs for traction. This system, it replaces the drivetrain that other EVs use. So as you can see here, this is the system that is commonly used on electric vehicles, such as Tesla or BMW, Mercedes-Benz, and other EVs. They all use very similar system. And our one, it basically replaces the full drivetrain by in-wheel traction system. So we remove most of the components from traditional drivetrain. So we don't have a gearbox, we don't have differential, and we don't need torque distribution to the drive shafts because everything is inside of the wheel. So we use axial flux motor, which has high power density, high torque. So the weight of the full system, the wheel, including the motor and the braking system, is the same as the wheel hub assembly, like brakes and the caliper and the upright on the regular car. So the weight of the system is about 60 kilograms, which is about the same as the wheel without the motor. So this gives you a perspective that the potential advantages in the weight and the space savings. This particular model here is designed for a sports car. It has 19 inches standard wheel, and it fits standard tire 19 inches. We developed a custom brake caliper and a custom brake disc, which is up to 3 times lighter than currently the similar system used in other vehicles. So the reason why we were so much paying attention to remove so much material from the brakes and optimizing it, allowing multiple topology optimization, is because this braking system is only used for redundancy, meaning that we don't ever need to use them. They only use them for safety in case our motor system, braking system recuperation will break. So in case of an accident, if any failure, then we apply the frictional brakes. Otherwise, we use 600 Newton meters of the torque from the motor to stop the vehicle, any electric vehicle. So because we don't have any of the gears and drive shafts and all the chain of components, this in-wheel motor is much more efficient than a traditional system. And so what ultimately it happens is that there is a lot of benefits in terms of the vehicle size, vehicle weight, and then we can make cars smaller, lighter, and then we save more cost on battery, for instance, or on vehicle structures, because everything is now shifted inside of the wheel. Now maybe you ask, okay, how about the serviceability? Because this is another question that many people ask. So what happens if I hit the curb? And what happens then? Would I have to replace the full motor? Well, in our case, it doesn't have to, because we have this interface here, which separates the motor and braking system from the wheel. So if the wheel is damaged, we can just replace the wheel by removing those 5 bolts and put the new wheel. And also, as you can see, these black pads here, they are damping elements. So when we hit the curb, they absorb most of the vibration from the road and impact. So it doesn't affect the motor so much. Of course, we get some of the impact on the motor, but we use angular contact ball bearings that take up to 2 tons of the weight per wheel. All this section is our rotor, so everything rotates with the brake disc and the wheel, and everything inside is the stator. So all suspension components, the steering, and free-phase interface, and brake caliper is directly integrated on the stator. So we have no upright, no extra parts, no extra brackets. Everything is directly interfaced on the stator. this would really cause the weight saving. So because we don't have a hub, and most of the weight, most of the torque, it's in regular cars, it's inside of the hub. Since we removed it, we saved about 20 kilograms of the weight, and these 20 kilograms we added back with electric motor. So the full system weighed exactly the same as the car will on the regular vehicle.